Once you open CATIA, the first thing you're going to want to do is to make sure that your units are set correctly. You will need to be checking the length, linear feed rate, and angular feed rate. You can do this by selecting Tools at the top of the screen, Options, then click the Parameters and Measure tab, click the Units tab and go to Length, and scroll to find the inches. Change the linear feed rate to inches per minute and the angular feed rate to inches per turn, then select OK. Next, we're going to open the part and create the stock. So what you need to do is open your part so that it's on the screen. Click on the Create New Part button and then click Product 1. Select the No option when the box appears. Go into the Properties tab under your new part and rename it to Stock. Change the color under the Graphics tab to a blue and change it to so it's transparent so that it's around 200. And select OK. That means when your part is created, or when your stock is created, you will have a blue piece that is transparent so you can see your original part. What we're going to need to do now is to actually create the stock for the part. Select the Sketch tool, and then select the bottom face of your surface. Now as you can see on mine, it was flipped so that the top face was showing. What you can do is select the normal to face operation, and it will take you to the bottom part of the material. Once you're on the bottom part of the surface, click the Project 3D Elements button, and click on the elements to project, and click on the bottom face of the part, and click OK. What that does is create a sketch that mimics the bottom of the part so that you can pad it up later. So now exit the sketcher and click on the pad operation. When you need to find the object to pad, go into your part tree and click on Sketch, and then enter an amount that will be about half an inch higher than your part that you are trying to create. Now we're going to begin the machining process. What we need to do is to set the machine parameters first. So go to Start, Machining, Advanced Machining, and that'll take you to the Advanced Machining window. Double-click on the part operation in the part tree. Here you're going to set the reference axis, identify the part, stock, and select the tooling catalog, and also create a safety plane. Go to the machine icon. Click on the Tooling tab and select the correct tool catalog. For our part, we're going to use the VHF1 tool catalog. Now, next you're going to set the reference axis. Click on the Reference Axis tool button, and it'll bring up the reference axis window. When setting the reference axis, you want to make sure that the X arrow goes along the long side of the part and the Y goes along the shorter side. This is because the CNC machines used have more area to move in the X direction than the Y direction. The reference axis is also typically placed on the bottom left corner of the top of the stock. Now we're going to select the parts that are going to create our stock, our part itself, and then create a safety plane. So what you need to do under the stock section is just click on the stock part and then double click on the blue stock that you've created. After you've selected your stock, you're going to create a safety plane. You have to make sure that the safety plane is 1 inch above the stock material. Click on the top of the stock to create your plane. Then right-click on the safety plane outline, select Offset, and enter 1 so that it is 1 inch above the stock material. This ensures that your tool does not collide with the part. Go into the parts tree on the left side of your screen and hide your stock material. In the part operation window, click on the part button to select your part and select OK. Now we're going to start our facing. Select the face mill operation and click on the Manufacturing Program 1 in the tree. In each operation window, you will have, from left to right, the Machining Parameters tab, Geometry tab, Tool tab, Feed and Speed tab, and Macros tab. Click on the Geometry tab and select the stock plane in the sensitive area and click on the top of the stock. Now to select the bottom part that will be face mill, go into your part tree, hide your stock, and select the top surface of your part. You will notice that the side contour will be highlighted in green because CATIA automatically created a limit that it believes is what you want. But that's not exactly what we're going for in this operation, so we're going to have to right-click on the contour and select Remove. Then going to right-click, select by boundary of faces, and go around each of the faces of the part and select them. You will then notice that under the face milling operation window, the sensitive areas will all be green. Click the Tool button and select the Face Mill button. Next, click on the Machining tab. For facing, you are always going to select back and forth. The machining tolerance for all the operations is going to be 0.001 inches. Make sure to change it. Click on the Radial tab and set the mode to step over ratio, and make sure that the percentage of the tool diameter is 50. Click on the Axial tab and change the mode to the maximum depth of cut. Change it so that the values are set to 0.15 inches. You usually will not have to do a finishing pass, but if you do, go to the Finishing tab and change the mode to Finish Bottom Only and enter 0.05 inches for the bottom finish thickness. Now click on the Feeds and Speeds tab, select the Transition and Spindle Out boxes only. Next to Transition, select Approach. For the machining value, under the Spindle Speed section, you want to determine the machine you are using and its maximum speed. The values are as follows. VAF1 is 7,500 RPM, VF3 is 8,100 RPM, and the DMS is 22,000 RPM. For machining value, under Feed Rate section, go to the Whitney Tool Company Feed and Speed Calculator to find what your feeds and speeds will be for each part. Enter the chip load per tooth value to be 0.005. Press Calculate and enter the calculated value in the Machining section under the Feed Rate section. Retract will be the same as the Approach. Now, select the Macros tab and turn on all the macros by clicking on them and then selecting Activate. Select the Approach macro and select the Remove All Motions button. Select Add Tangent Motion button, then select the Add Motion Perpendicular to a Plane button. To the value on the tangent motion, double-click and change it to 2 inches. Then select Copy Approach macro button. Select the Retract and repeat the steps from creating the Approach macro. Click the Replay button, analyze the part, and then select Cancel to get out of the analysis window. Select OK to exit the simulation window. Be sure to select OK to get out of the facing operation, because if you do not, you will have to redo it. Save the files as the book tells you frequently. For the next operation, we are going to create a pocket on the top of the part. Select the Pocket button and then click on the manufacturing program in the tree. In the sensitive area, select the Open Pocket and change it to Closed Pocket. Select the bottom plane in the sensitive area and click on the bottom of the pocket. Now you'll see the side will turn green, but you need to right-click in the sensitive area and remove the contours along the side. You will then click on each of the edges of the top surface of the pocket. Go to the Tool tab and change your tool. When selecting a tool, you want to make sure that it will fit into the radii of the pocket. You can go check the size of the radii by clicking on the Measure button and selecting the radius of the pocket. You can now determine the diameter of the tool you need to use. Select the Machining tab and change the machining tolerance to 0.001 inches. Click the Radial tab and change the step-over ratio to 30. Select Axial and change the maximum depth of the cut to a value that is about 50% of the tool's diameter. Select the Finishing tab and make sure that the mode is set to No Finishing Pass. Go to the Feed and Speed tab and use the Whitney Tool Company Feed and Speed Calculator to again determine the feed and speed values. Select the Macro tab and turn all of your macros on. The approach and retract macros should have a perpendicular motion to plane. Click the Copy Approach button while on the approach macro, and then click the Copy Retract button while on the retract macro. Select the Play Toolpath button, play and analyze. Select the OK button to analyze, and OK again to exit the pocketing window. The last operation we are going to do is the Profile Contour. Click on the Profile Contour button. In the Geometry tab, select the top plane and then select the top of the part. Select the bottom plane in the sensitive area and select the top of the base block. Then, right-click on the vertical area in the sensitive area and remove all the contours. Click on the vertical area in the sensitive area and then click on the top edge of the part. Click on the Tool tab and select a tool. You're going to want to select the largest tool that would be able to get the job done, but ensure that the tool is an end mill. We are going to use a 5/8 inch end mill. Select the Machining tab and make sure that the machining tolerance is 0.001 and the toolpath style is one way. Click on the Step Over path and select the Step Over First box. Change the distance between the paths to 50% of the diameter of the tool. The maximum distance between the paths should also be 50% of the tool diameter. Note that if you play with the simulation and there is excess stock material, return to the Machining tab and increase the number of paths. Go to the Feed and Speed tab and enter your calculated values. Then go to the Macros tab and activate them all. For both approach and retract, you are going to first clear all the motions, and then add circular motion, and then add a motion perpendicular to the plane. For the circular motion, change the radius to 0.5, copy the approach and retract macros by selecting the copy button for each. Then click Replay button and play the simulation and analyze. Once you are done, be sure to save your process. That is all we have for today. In our next video, we will be covering Chapter 4.